Okay. Good morning, everyone.
Morning.
Good morning, ladies and gentlemen. I can say most of us are gentlemen. I'm Carrie Cole from Afore. It's my pleasure to welcome all of you come from many different countries to join us in this Afore Technical Conference here in Frankfurt. Our guests are from different countries in Europe, for example, like here in Germany, in Italy, Spain, Belgium, Netherlands, Croatia, Serbia, etc. Most guests are our faithful old friends who have been working with us for many years. And also many of us are our new friends who started working with Afore. This will be a very good opportunity to get to know better about Afore products and technology. We also are very glad that we can take this good chance to hear from you, to share your best knowledges and experiences in this industry. During the conference, we will mainly introduce the following topics here about Afore's brief introduction, certifications, our product technical features, system application installations and operation, troubleshooting and maintenance. Maybe in the morning of the second day, we will have the monitoring operation web and app demonstration. You will find behind on your chair, each of your chair, there is a bag. Inside it, you will find a catalog, one pen, and a pad to take notes on, and a small gift, which is a Bluetooth headphone from us. And after each session of the training course, about every 45 minutes, we will have about 10 minutes Q&A sessions for you to ask questions to our engineers and our staff, so that we can discuss together and interact together. And after the Q&A session, we will have a short coffee break in the opposite side of the reception desk. You will find the drinks and the juices just beside the door. You can get whatever you want. And now I will start from our first part about Afore. I guess many of you have visited our factory in Shanghai. Yes, we are located in Shanghai, and we have more than 14 years PV inverter manufacturing experience. Our company was founded in the year of 2010. Afore is one of the top 10 string inverter factory in China, and in total shipped more than 8 gigawatts globally. We have more than 230 solar inverter patents, which include software-related, hardware-related. The area is 20,000 square meters. The total employee number is 300 people, and 20% of us is professional engineers. And we also have an independent R&D lab in our factory. The key components which Afore's all product lines include, for example, the capacitor is from Mishcon, the current transducer is from VSA and Lam, the IC, the chips are from TI, from United States, Texas Instruments, and this is switch from Bay and IGBT, especially from the Japanese manufacturer, which is Infineon. And cooling fan, the intelligent cooling fan is from Delta. That relay is from Panasonic. You can see that we will never reduce the cost on the key components, because we need to make sure that our inverters life design life and the performance will be very steady and good quality. We offer not just good products, but also high efficient and local support to our partners and users throughout the inverter lifespan. For example, during our test, each inverter must go through very strict functional test, ATE test, and 4 to 8 hours aging test before pack. Each one of them will go through this test. This is our global market map. In the blue areas are the countries that we have sales offices. For example, in UK, in United States, Mexico, Japan, Russia, Ukraine, Australia. And for the green parts, for example, like Brazil, Sri Lanka, Spain, Belgium, we have local partners that work closely with Afore to establish the distribution channels and after-sales service. In some countries, Afore has the market share about 10 to 15%. About the hybrid storage inverter for the single phase one, we have, for example, 1 to 6 kilowatts single phase low voltage inverter, which is our normal version, has a charge and discharge voltage like from 4 volts. And this year we have our new series, it's called single phase 4 to 6 kilowatt plus series, which means it has bigger current, is 120 amps, which means that will enable the inverter's EPS output power bigger. For example, 6 kilowatt, the EPS output power could be 6 kilowatt. For the AC couple units, we have 1 to 6 kilowatt. It can be used for the existing PV on-grid system to be expanded to the solar storage system. And the last one is related to the US phase hybrid inverter. Some of our European partners, they also have their arrangements in the US market, might be interested in this product. This part is the high voltage solution, mainly for 3-phase hybrid inverter. Start from 3 kilowatts to 20 kilowatt, to 30 kilowatts. In the first part, 3-phase, 3 to 12 kilowatts, normal version. Why we call it normal version? Because in this industry, most of 3-phase hybrid inverters charge and discharge current is about 35 amps. So that this normal version is. The second one is 3-phase 15 to 30 kilowatt. This is mainly for commercial and small plant application. The third part, 3-phase 3 to 12 plus series, means the charge and discharge current is about 50 amps. It will have the bigger power, output power under the EPS mode. Our colleague later will give more details about this part, about this new product. We'll be a little bit curious about the last one, delta voltage. Our partner from Norway or Sweden might be quite familiar with this one. This is for the special delta voltage grid, which is 3-phase 220 volts. Also, this application is suitable for Mexico and other American countries. This part is our battery products. We have 2 major categories, voltage and high voltage. Low voltage from 2.5 kilowatt hours up to 10 kilowatt hours. The high voltage, each pack, we have 2 types. One type is 2.5 kilowatt hours per pack, and the other type is 4 kilowatt hours. It can be stacked up to 42 kilowatt hours for the high voltage battery. In the top of each high voltage battery solutions, you will find the PDU box. PDU box is integrated with the BMS and the high voltage package. About our certification list. Certification is really, we can call it a really annoying barrier for each solar industry for the different countries. We have to spend a lot of time, energy, and money for different certifications. For the inverter certifications, regarding to the safety standard, grid connection standard, and EMC standard, for many different countries, like for the most normal European countries, EN 50549, for Norway, UK, Netherlands, Germany, Poland, Belgium, Italy, and Spain. Like Mexico, North America, Australia, South Africa, etc., and IEC standards. This one is the certificates list for battery. Battery is much less than inverter. Mainly is the CE, IEC safety standard, and UN, UKC, etc. Except for the standard, except for the certification and test reports, many countries, especially in Europe, the grid company or the grid authority, they have their own publicated approved list. Many of them, they have their own website. For example, Belgium, Hungary, Denmark, Austria, UK, Romania, Tunisia require us to submit all the relevant documents like.
Can we get a copy of this?
Of course, gentlemen. I will send all the details to you by email. The part with the check is the list we have completed. The part with circles is during application. Okay, my part is, for now, it's just this. Next part, I will ask my colleague Dong to give you this introduction about our product technical features. Thank you.
Morning, ladies and gentlemen. I'm Dong from Afore. It's my pleasure to deliver all these product technical features, applications for you guys. I'm kind of nervous right now. And I prepared a long note because I don't like deliver the content from the PPT. I will try my best to deliver more information to you guys out of the page. Okay, let's go. So right now, many people know it's good to go solar, but for us, it's to go storage even better. Some of there are many of benefits to go storage. You don't afraid of raising electricity bill, and when you face the great outage, you will continue can power your home appliance, and that makes your home and user energy independent. And right now, all the hybrid inverter equipment with smart and cloud information that user and operation and the maintenance guys could check the system status anytime and anywhere. Some of the upgrade things and parameter setting things can be done online. And with development of smart energy technology, storage inverter in the future will be widely used not only for the PV, but also for the other kind of renewable green resources like EV charge and etc. Hybrid inverter equipment of different operation models like the peak shaving, time of use. This operation modes could help users to reduce their energy bill from grid and change their habit to energy consumption. So this picture is show the block diagram of our single-phase hybrid inverter and the three-phase one. So when we're back to the single-phase one, there have some major features. For example, both DC side and the AC side, we will equipment with the surge and lighting protection. And the unique of we use of latest generation of the TI digital processor that will help the inverter become more intelligent and smart. So we have more efficiency from the MPPT maximum power point charging, and from charging points they have more efficient compared with other competitor. And also the inverter will be more quicker response to this switch time during switch on-grid mode to off-grid mode. Normally all of inverter can be finished the switch time within 10 milliseconds. And other intelligent production like hour and low voltage or hour and low frequency production and temperature production as well. For the three-phase hybrid inverter, we have unique of 4-bridge design for the inverter circuit. Under this design, the inverter can support unbalanced load. So unbalanced load for this three-phase 10K and below includes the unbalanced load could support 200%, and for the big model size up to 30, it could support 100% unbalanced load from EPS side. In the later part, I will provide the detailed information about this unbalanced load. And the whole three-phase hybrids have share the same control board with a single one. Also, the same latest version of TI DSP. Sorry. So make sure the better performance and also the intelligence. So from the charts you can see for the three-phase inverter we have buck boost. This part can increase the battery voltage internally, make the transfer and conversion efficiency more better, and also give the inverter more capability when discharging and charge. Here's our models for the single-phase hybrid inverter. Right now we have 3 series. One is normal version from 1 to 6K. It's 8 amps. Amps is discharge and charge current. And also we introduced the new version from 4 to 6. The discharge and charge current is 110. So compared with the normal version, the plus version have more capacity to deliver the power to the EPS loads and more power discharge and charge capacity for the batteries. And also the AC coupled series from 1 to 6 for the existing PV system. It's very easy to add these storage functions. You don't need to change the configuration of existing PV panels, and you don't need to change also the wirings of all the system. Just add and play. So all of our single-phase hybrid inverter is working with a low battery packs. So the lower, here is a picture to show the system wiring of the AC coupled one. So it's very easy. Just click the install the meter or CT on the existing system. No matter this existing inverter is a full version or third party, it can be compatible with easily. And this part is for the new system. So you can connect the normal PV panels, storage, and power the critical loads. And you can also add the smart load. Smart load means some of these boiler. So when you choose self-use option mode, or PV panels cannot when the battery is fully charged, loads cannot consumption the excess energies. The smart load will turn on to get this energy from PV side, and also the single phase hybrid inverter have a capability to connect with the generator as a backup or peak shaving, and with extra ATS kits. The later page will deliver some of the key features of previously mentioned three models. This is a normal version, and this is a plus version. All these models we have IP65 production level. That means you can dust proof and low pressure waterproof. You can install indoor, outdoor. All of the normal version and the plus version have the 1.5 times of PV hour size capacity. When you do this, later we have a chart why people it's better to choose the PV hour size. They will give the system actual battery discharge and charge capability. Also, all of version have the UPS level of switching time. From on-grid mode switch to off-grid mode, it's within 10 milliseconds. For some of the system, if the system capacity bigger than 6K, so the inverter can be paired connection. The maximum connection units right now is 6 units. The inverter, normal inverter and the AC coupled one, they all have share the same manual structure and operation models, like time of use, self-use, etc. For this detailed operation mode, I will provide more information later in the later page. So all the version inverter equipment of built-in anti-phase function, and we provide the Wi-Fi dongle and standards, so the users or operation or maintenance guys could do the upgrades, firmware upgrades remotely, and also some of the operational mode and the parameter setting could be done online. And for some of country or regions, they need the artful circuit interrupter, so we put this as a optional to meet the local authority requirement. So this is the AC coupled one. Compare with a normal inverter, the plus version. Compare with the normal inverter, the plus version have a bigger discharge and charge current up to 120 amps. The plus version will charge the battery more quicker than the normal one, and deliver the more power during the off-grid mode. That's a major difference compared with normal version. AC coupled inverter have the same features of with with a single phase normal version and plus version. It's easier and economic to add the existing PV system and without change the system panels configuration and the variance. So when you look through the data sheets, you will find compare with other brands. Afore single phase inverter have the more bigger PV input current. So under this current range, you can choose majority big power panels in the market, like up to bigger than 20 watt panels on the market. So with this capacity, you can compare with majority 210 and 182 panels in the market. So this chart is to show why we choose the PV hour size. So if you, for example, if the 5K inverter or 6K inverter, when you go 1.5 times PV hour charge, so if the PV deliver more power, so the inverter could deliver to the load more power, and in the meantime deliver the more power to charge the batteries in the same time. So here is a picture of examples for the 6K single phase 1 plus version. They have more capacity to deliver the energy to when under the EPS mode, and compare with other brands, the plus version could connect some of the big load like the air conditioning motor. For the 6K, it can power the air conditioning 2 kilowatts air conditioning and also 2 kilowatts motors. We know when this similar motor load starts, they will give very high current. So that this plus version can provide enough power when this load started. And this LLC is kind of circuit design mixed with some of the three types together. We compare with other brands. The inverter use the LLC circuit will around 1 or 2% higher than the normal ones when we get the calculation. So it can save 0.1 kilowatt hour of electricity per hour. So if the storage system working all day long, so the more hour the storage work, the more energy you can save compared with other brands. Also, this cooling design could help the inverter and the full load output or charging and discharging capacity during the high voltage have no derating. So that's the features of single phase 1. For the 3-phase hybrid inverter, we have this series. Normal version from 3 up to 30, and also for the 3 to 12 models, we have plus series. The many difference plus version compared with normal version. One is the plus version have bigger discharge and charge current, and another is the plus version can accept the lower threshold of battery voltage. That means for some control regions, this kind of power range is mainly focused on the residential one. So that will provide more flexible battery configuration for this kind of application. So another series is from 3 up to 70K Delta version delta voltage version is working for the American or the North Europe markets, where they have the low voltage three-phase 230 grid. And the later series is AC coupled one. Power size is from 3 up to 30. So when we go through all the features of three-phase inverters, also all of the three-phase models, we have an IP65 protection level. Also, it's maximum 1.5 times the PV hour size capacity. For this normal version, from 3 to 12K, the string current is up to 20 amps. So right now it can compare with all of the panels in the market. And in the future, when the panels power increase up to 700 each, within this capacity, it can be also configurable. And for this bigger power models, the string current up to the 40, the same as 20, because it's a 2 MPPT channel design. So all of these three-phase inverter, they have a UPS level of switching time, less than 10 milliseconds. And all this normal version and the plus version, they can support and balance load. So 100% unbalanced load for the power for the models from 12 up to 30 and below 10 included is 200%.
Question.
Yeah.
This Plus series seems to be able to start with lower battery voltage than the standard version. Is this true?
Sorry. All these three-phase hybrid inverter we need to connect with high voltage battery bank.
Here you say 80 to 600 volt batteries. So starting voltage is 80 volt.
Yes, and
For the
no
standard series it's more high.
standard one is 150.
Yeah.
So plus version is 80.
So if you have two battery blocks, 50 volt each, you have around 100 volt. So you can do it with the Plus series, but not with the standard.
Yeah.
Okay.
And all these series will have built-in anti-phase functions, and Wi-Fi provided as standards, so it can be configurable or upgraded remotely. AFCI also is optional. Normal version and the plus version includes this Delta version and AC coupled version. They have the interface to connect the support generator both as a backup. All these three-phase inverters, they have the same manual structure, same functions, and the same operation models. Also in the later, we have deliver more detailed information for these operation models. Compared with other brands, for the three-phase hybrid inverter, each MPPT current input panel is 20 amps. So that's the capacity to comply with all of the panels in the market. So this below chart is also the demonstration to when the inverter is our size design, so it can deliver all this more power to the grid and more power to charge the battery in the same time. So in the battery mode, you can achieve a maximum 1.0 times of off-grid output from the inverter side, and it can carry power the air conditioning load and the motors load. Here's the difference of A4 string three-phase inverter with other brands. We use silicon and carbon devices in the energy management circuit that can reach up to 98% efficiency compared with 48 low voltage three-phase ones. So that's the gap, the most 5%. So when the system working for the whole day long, this kind of gap will give more energy generated to the users per day. So compare with a high voltage battery system and a low voltage battery system, and we can see the trends on the market. Majority of the inverter company, for the big power size three-phase inverter, they go high voltage topology. This have some few benefits to go high voltage solutions. For example, for the inverter side, the topology of the inverter will be simple, and the efficiency both on the inverter side and the charge controller side will be higher than normal one. You go the high voltage battery, that means the battery has a high voltage and lower current. But the low voltage system, they deliver the very high current with low voltage. That means for the high voltage battery system, they can get less conversion loss or transfer loss. And for the charge and discharge converter efficiency, this kind of high voltage topology will be more structure simple and smaller in size. So this is a detail. This is the example or detailed information for the unbalanced output. So from this picture, we saw its numbers delivers a little bit smoothly. We see for these models, we mentioned for the models below 10K and included, the EPS, this part, EPS output can be achieved 200%. That means each airline, for example, for L1, 10K, it can deliver 6.6K energy, and another two line keeps zero. And under these extremely conditions, the inverter still works. For these models from 12K up to 30, this part can deliver 100% unbalanced load. So it's a three-phase hybrid inverter. When the grid is done, they can deliver emergency power put three-phase one. But in our home load, not always the three-phase one. We have also some of the single phase to connect with. So in that case, it will be cause the energy imbalance for each phase. So within this design, even under the EPS mode, the system works, and the inverter can handle this kind of different for each phase energy. Also, compare with the other brands, the A4 delivers 3 to 30K power range. The most power is 15 or 20. And for this capacity, mainly for the batteries, although we have our own battery bank, but we can still give the battery selection flexibility to our customers. They can choose their battery under our white list. So other brands, they deliver the inverter with battery together as a kit. So for this parallel connections, we introduce the new technology of AI equivalent power and current. And this technology, the three-phase inverter, when you especially for this industrial application, the parallel connection quantity have no limitation. For this charge and discharge, for the charge points, three-phase inverter have the less charging ripple current. That means will reduce the bottom of BMS and prolong the lifetime of the battery pack.
So this part is finished. So gentlemen, ladies and gentlemen, if you have any questions, you can raise your hand or just stand up to ask us. So we can try our best to answer your questions.
A question regarding the lifespan of inverter box. The standard lifetime, people say it's between 10 and 15 years. Yeah. If you take a typical system, maybe 10 kilowatt system, 10 kilowatt modules, 10 kilowatt inverter and 10 kilowatt battery. If you choose instead of the 10 kilowatt inverter, maybe a 15 kilowatt, will you gain lifespan?
Related?
I'm not really sure. I might have to ask a few questions and come back to you on that one, because theoretically you're right, but whether the optimum setup of our inverters as they are at the moment gives its optimum lifespan anyway, and it may not make much difference as far as the size of the solar array that's on there. But I understand the question you're asking. But I'm not absolutely sure. Is my understanding as far as that.
Because the price difference is not so high.
No, that's right.
15 kilowatt machine. Yeah?
Yes.
So if you gain 3 years more lifetime, it would work.
Yes.
I mean, the point is you have less load on the inverter, but then on the other side, there might be a question of efficiency. So
The efficiency shouldn't matter that much, because between, say, a 15 and a 20, the startup voltages are identical anyway. So the efficiency should still be the same.
on paper.
I think the lifetime of the system, not only the system and the inverter and batteries, have some relation with users' habits. What's their operation models they do? How long they will use this kind of system to discharge, charge the battery, and how many cycles they will done by per day. So if they do more frequently per day or in a certain time, I think the whole system's lifetime definitely less than the normal one.
Yeah, well, we'd say minimum 10 years anyway, wouldn't we?
Yeah.
Well, especially for the batteries, I guess. If the capacity is higher, you have a lower C rating, so the battery has a longer lifespan.
Yes, yeah. So that is a good point. If you oversize the batteries more, you discharge it at a lower rate to restrict the C rating. I'd probably only recommend about 0.5 C anyway on the batteries to give them the lifespan that we would expect to have.
Yeah, but that makes sense if you over-capacitate your battery system for a longer lifespan.
But plus the other thing with that is things like using time of use tariffs, where you're charging it AC over the winter. You need a bigger capacity battery if you're calculating what the daily use is.
What about global MPPT, aka shadow management from the inverter side? So do your inverters provide that?
Sorry again. Sorry again.
Do your inverters provide any global MPPT shadow management? Yeah, that's what you find on, for instance, S&A inverters. So they regularly track the whole spectrum and set the optimal voltage.
Yeah, we do PPT circuit design, which can keep tracking the maximum current and voltage and find the best one. Is that what you mean? Like the two, for example, we have two independent MPPT channels, and for some of the models like three-phase string inverter, for example, 60 kilowatt, we have three independent MPPT channels, which enable different directions from the rooftop installing PV. When we went through previous parts, at that time maybe you have some doubts. If you have recited it, if you have made notes on that, you can put forward questions to us about our products or data we have presented.
Yes, or later we can discuss after the meeting if you have one. So,
If we don't have any questions, we can move forward to outside the coffee break corners to have a rest. Hopefully this the pure technical training is not making you fall asleep. Boring.
the coffee break corner is in the left hand when you enter the lobby.
In the opposite side, 你带一下。
So we will take 10 minutes break.
10 to 15 minutes.
Okay. So we go on. Also, for some applications, if the existing system is three-phase inverters, and the majority of home load is single-phase one, you can also choose these solutions. Add this AC coupled single-phase unit to the existing three-phase grid connection system. So the difference is you need 2 meters to tell. One is to detect the generation from the existing string inverter, and another is to detect the energy flow totally to tell this AC coupled inverter when needed to discharge, when needed to realize the zero injection function. So this is typical single-phase hybrid inverter storage system. You connect with the AC, you connect with panels, batteries, varying the critical loads, and varying the meter or cities, and also if the home have the loads, a smart load, you can add a contactor to turn on this smart loads automatically. This scenario happens when this PV energy is too much. During the same time, the battery is fully charged, and the local load cannot consume the excess energy. And in this area, no loads fit into the grid, and under these conditions, the smart loads like the heat pump will be turned on automatically to consumption such of this excess energy. And also, the generator could be connected with the actual, we call the ATS kit. This generator could be works as a backup or peak shaving when there is no grid. And during the night, no PV. And also, the battery is low, so the generator could provide the energy to the load in the same time could charge the battery. Or if the grid is on, so the generator could be act as a peak shaving during peak hour price rating. That's this condition is very not the normal one. This is a typical system wiring of the three-phase hybrid inverter. The same with the single-phase one, and the same function you can connect with a smart load and a generator as a backup. And for the three-phase models, we provided smart meter as standards. The difference is for the low power size hybrid three-phase inverter, we provide the smart meter supports the load up to 50 kilowatts. And for the big size, we provided a smart meter which can support a big power load like 500 kilowatts. In that case, it's a meter with 3 cities together. So for the hybrid inverter, no matter single phase one or three phase one, their mainly functions on grid and off grid together. When you get the on grid, the inverter's operational mode is meaningful, like the time of use, the peak shaving, and the users could, according to their energy consumption habits, choose the right operation mode to realize to reduce their energy purchase from the grid or during the low rate electricity rate hour to charge the battery from AC side and discharge the battery, provide the load energy during the peak hour. And when the system go off-grid mode, so it's the inverter, the battery will provide this energy to the critical loads, and if the system equipment connected with the generators, the generator also can work as a backup when the battery or the loads needs the excess energy which the PV panel or battery cannot fill the gap. This picture is a typical energy flow or the charge of discharge state of the batteries of the hybrid system. During the daytime, the PV energy will provide the load forcefully, and the excess energy will charge the battery. And if the battery is fully charged, the actual energy will go into the grid. And during the peak hour, the battery will be discharged to supply the consumption to save the energy bill. And during the night, in some areas which the peak and high and low different electricity rate supplies, the inverter, according to the user's setting, we have a time of setting 4 times or 4-time period setting. According to this time setting, the inverter can charge from the AC side to the batteries during the lower rate electricity hours.
Is there an API that reads out the flat tariffs on the net? How do you know when it's flat tariff on the net? There's a syncing you said, right?
Sorry again?
When you use dynamic charging from the grid, there's a syncing. Is there an API or how does it know from your local tariffs?
It's different. I think it's different from country to country. In Japan, we have a central router. They can read the government's forecast or these prices automatically to tell the inverter which time to discharge, which time should be reduce the production. But I think majority of markets, the user should check with a local network company which who they sign the purchase contractor to check their official online the peak hour and the low peak hour or low hour rates to set their specific time period to when to discharge, when to charge.
Is there an open standard or an API or something to talk to when it comes to the inverter? Can we instruct the inverter with some kind of message to start and stop?
Currently, you set those times in that you want those times
In the app.
to come on and go off.
Okay.
So you set,
You have to do it manually.
yeah, do it manually and set it, and then you can just leave it, and then it'll automatically come on at those times when you set it. And there's also a
Prices goes like
Yeah, that's on daily basis.
your daily basis, hour by hour.
So is there
Hour by hour is mainly for this Netherlands market,
is there
Norway.
some kind
Norway.
do you not have set times when you have the peak and the
No,
of
it changes day to day. One day it can be half euro and the next day it can be free at the same hour.
right?
Yeah,
Okay.
you never know.
Okay.
helpful if there's some kind of API or open standard where we can send in messages?
Yeah, that's a good suggestion for next step, make the inverter and the storage system more smart to according local time of use rate.
I mean, the question is about the programming interface. I don't know if you're familiar with the term API.
Yeah, we can open the API.
Okay.
You have
To-
an API?
Yes,
Okay.
but we this API mainly we opened it to only some of data transfer or data transfer. I haven't.
Yeah, if there's an instruction where we can start and stop the inverter actually,
Mhm.
then that's the solution for the dynamic loading.
Yeah. Okay, we start. For the single phase and the three phase hybrid inverter, they are designed on the same control platform, so they share the same menu structure. They have the same operational mode and the same settings. So we put the single phase and three phase together to introduce the operational mode. So for this operational mode, we have self-use mode, time of use mode, ceiling first, and backup. That's the four major operational mode. So we're back from the previous one. The self-use mode is for the regions with low feed-in tariff rate and with high electricity rate. So the energy produced by the PV will go to, here is the energy flow. The PV energy will go to the load first lane. And if the load cannot accept them all, the excess energy will be go to charge the battery. When this battery is fully charged, still have the excess energy, they will go to the grid side. Yeah.
So, check the load. But the battery is always charged before it's converted to AC, right? So it goes to the MPPT, doesn't go to the AC first and then back from AC to DC.
Yeah.
So it will charge directly from the MPPT to DC.
Yeah, exactly.
Correct.
So the load is not all ahead. Check the load, but it won't go first to the load and then back. It will check the load if it's loaded, and then charge it directly from MPPT to the battery.
Yeah. The first priority is to go to the load.
Yeah.
Because the inverter have equipment with a smart meter or CT,
Yeah.
it will detect the energy direction.
Yeah, so that's the most efficient, right? Otherwise you will be converting 2 times.
Yeah, exactly. They will not charge from AC side because the energy will convert again.
Exactly. So it will check the load and then otherwise it will charge the battery directly from PV.
Yes, from this PV side. So any question if you have, you can interrupt me and we discuss. For the time of use mode, we have three sub menus. One is charging setting. Charging setting, you can check they have a charge from PV side and also from AC side. Another sub function is forced discharge. Another is forbidden discharge. So for this time of use mode is designed to the customer who do this reduced demand on the grid energy, especially during the peak hour. So no matter from charge from PV side or the AC side, they both have 4 period of time charge setting. That means you can set in the charging time from which hour, start from which hour, end from which hour. This kind of setting and 4 period according to your user's energy consumption habits, and also check with the local grid rate. So for the PV charge mode, the energy flow will be provided, will charge the battery forcibly. After the battery fully charged, the energy will provide to the load, and the excess energy will go to the grid. For the AC charge mode, the energy flow will also charge the battery forcibly. But in this time, PV and grid power will be work together. When this PV energy is low during the nighttime, so the grid will be fill the energy gap to charge the battery forcibly to a certain SOC. Then excess energy will be go to the load. Forced discharge mode also have a 4 period of time discharge setting. The energy flow will be battery and the PV provide the energy together to the load, and then excess energy will be go to the grid during the daytime. This is during the daytime, and during the nighttime, the battery will be forced discharge to the load. This is especially during the peak hour of the electricity rate. This kind of time can be use the cheap energy from PV and battery to lower the energy consumption rate. Forbidden discharge, when after setting the period of time setting, during this period of time, the battery will not discharge. The energy flow, PV energy will charge the battery forcibly and go to the load and then to a grid. Under these conditions, if the user have a special usage for this energy in a certain time, they can set in such of the time period and the energy will be discharged in the certain time in the future for the future use. Ceiling force. Ceiling force is not the common one, but for some of the regions with high feed-in tariff, it will be make sense. So the PV energy will go to the load, feed the load forcibly, and feed in the grid to get the subsidy, high subsidy, and then go to the battery. Someone will have a question because the grid is kind of big battery bank. They can why the inverter have the extra energy for the battery. So when that's the reasons when the PV oversize designed generates more power than the inverter rated output power, because the inverter's output power is limited. If the energy from PV side bigger than the output power of the inverter, plus the local load consumption, the extra excess energy will charge the battery in the same time. So for this procedure, any questions?
For 120 amps, the 30 amps extra will go always directly to the battery.
Sorry. Okay.
So in the app, we can choose which model for the working, right?
Yeah. The user could choose which operation model on the app,
Yeah.
or on the inverter setting.
Okay.
The question.
Yeah.
On a standard private house, the limit is the space of the roof. You have a certain amount of square meter available on the roof. Maybe you can put up maybe maximum 10 kilowatt PV modules. Yeah. What option is the best solution usually?
You mean the battery solution, the battery capacity solution?
Yeah. No, the priority solution. What is the best?
Self-use, normally.
Self-use
Yes.
and mixed use gives the excess energy to the electricity company. Yeah.
Yes, on
What would you
self-use.
propose?
Yeah, so on self-use, it will go towards the load first. Anything surplus will go into the battery. Once the battery is fully charged and the load's satisfied, it will then export it back out to the grid. Certainly in that situation, I'd say probably 80% of the time, the best setting on the inverter would be self-use.
So the last one is backup mode. So when the grid falls, the system will be switched to the backup mode, off grid mode directly. So the energy flow will be PV provided the energy to the battery and to the load. So when the PV power or the battery power is low, the generator will be turned on automatically to supply the gap of the load. That under these conditions, that if the system add the generator as a backup, especially during the nighttime or dawn in the morning or the dawn in the day, so the generator will make up the gap between for the load. So this part is the same way Dan explained before. And we have two conditions to choose the hybrid inverter. So for this country or regions with unsteady grids, you can use this hybrid inverter majority or part-time working operation and the off-grid mode. So for this country or area with steady grid conditions, this four operational mode is meaningful. They can do the peak shaving. They can do time of use, and make this energy bill from grid significantly reduced, and save the energy bill. So except previously applications, the string inverter also have some other special uses. For example, the hybrid inverter can operation without battery. For some of the users, they want the hybrid inverter, but later they install the battery. It can works. Just under this condition, the hybrid inverter works as a normal grid connection inverters. And later, when the battery is on, they can do some of peak shaving or off grid backup. And also in some areas there are no PV, just have the inverter and battery. So during the peak hour, they can do this peak shaving to get the cheap energy charged in during the peak hour, discharge. So in that case also can save energy bill. So the later one is purely off-grid inverters with for this area have no access off-grid. The part is mainly for the parameter things for all of single-phase inverter and three-phase inverter and AC coupled inverter.
I have a question about the off-grid mode. Does the inverter start without a grid connection? Can you make it start without a grid connection?
Yes, that's the features of hybrid inverter. They can both.
Most of the hybrid inverter don't have that feature.
And just the backup is working. But if without battery,
I understand, but
grid is off.
a lot of different suppliers don't they don't offer off-grid without an initial grid connection. So they don't start without an AC coupling.
It's called backup feature.
Now I understand the backup, and I know all the inverters in the market, but mostly they don't. They really don't have a backup function without an AC coupling.
It will start up and it will run, but it won't put any power back out of the grid side. It will work out of the
An island mode, let's say.
Yeah, absolutely, yeah.
And he also said it will start without the PVs. It also runs without PVs.
Provided it's got battery.
Yeah, okay.
Yes.
That's a big function. A lot of suppliers don't have that function, island mode.
Yeah, but it won't put any power, like I said, it won't put any power back down the AC. Yeah, because there isn't an AC, but it will put power out on the essential circuit supply. But you do need to be a little bit careful as far as calculating what the maximum output of the inverter is for what the load you put in on to the system. Yeah. So if there's a power cut, for example, if it is grid connected and there's a power cut, it'll cut the load off back down the AC side, but it will actually keep the solar panel generating, charging the battery and running the essential power supply. So in the daytime, you haven't just got the capacity of the battery, you've also got the charge and discharge capabilities from the solar itself that is providing power to the essential circuit supply. So it's not like you've just got, say, for example, 1 kilowatt run for 5 hours and then nothing happens. It will keep the battery charging during that period as well.
But for example, for a van or something, for something off-grid or caravan or an island system that doesn't need per se a grid connection.
Yes.
Normally,
Providing the wire is right on the bottom of the inverter, provided the right connection. Yes.
Okay, we'll continue. Yes, for this parameter things, it's mainly to get the guide when you design a system, which is it has several points need to be noticed during your design the system. For example, this is AC coupled one. We get this normal one as an example. So for the new system, when you design the system, you need to calculation how many panels you need to be connected, how many strings. So how many strings is depends on the inverter, how many MPP channels they have. And for each string, how many panels you need to connect in series, you will consider two things. One is the inverter's maximum DC voltage for the split panel, and also we also provide the full MPPT range. That means during this range, the PV panel's voltage, the inverter could tracking do this maximum power point tracking more efficiently, and also the inverter can output the reach the rated power fully. So when you design the string voltage, not past this upper limit, and it's better to inside this range. That design is good. Also, if you check the panels data sheet, they will provide the for this voltage. They provide the VOC voltage of the open circuit VOC, and IMP, the current maximum power current of each panel. Also, they have the temperature coefficient. So the temperature coefficient is used for the winter and summer. When the temperature drops more, the panel's outputs for the especially for the VOC will increase. So if you design this system manually, you need to take this points considered. Otherwise, the inverter during the summer is working good, but in the autumn or winter, when this temperature is low and the sunshine is good, the string voltage might be past the limitation because the coefficient from panel character issues. And another point is when you design the battery, make sure your battery bank's voltage within this. The AC side, AC grid is okay, and hybrid inverter can work both on grid and off grid, especially off grid one. You need to know the inverter's limitation. The power output limitation from an EPS port. If you connect with a big load to this inverter, not much the range. When you off grid, when the grid is down, the inverter cannot power the load because the load is too much. And when you consider the load type, they have two types. One is resistor type, another is capacitor type. So these two type of load, the character is completely different. For example, if the loads have the motor inside, especially during the very start period, this kind of load will need more current than back to the normal rated. So this should be considered because we also give the suggestion for this peak current amps, and also this time means during this peak current number, the inverter could support continuous works for 10 minutes. During this time, especially for some of motor rates, after they can provide the continued energy during the peak hour and then steady, makes the loads working smoothly when the grid is off. So that's the point should be noticed during the system design procedure. The same with three-phase one. Our next topic is how we design the hybrid system steps. So nowadays, many people use software like the Valentine or PVCs do this kind of design. It's more convenient. Also, we have already registered all of Afore single phase and three-phase hybrid inverter data sheet parameters into their database. When you do the upgrades, you will find the Afore model in their database, and you can choose the different brands of panels, different battery, and with the Afore inverter, the system software will, according to your input data, generate a well-designed system. And also they can generate the detailed report. What's the configuration of PV sites? What's the configuration of the battery site? And what's the forecast for this kind of system for a all-year generation and consumption according to your country position or area. And also they can input some of financial.
Which system are we talking about? Which PV planner are we talking about?
PVCs and Valentine. This software is very convenient. You just select the panels, inverters, and batteries. The system will generate the.
Is that I don't know that system. Is it on online platforms?
This okay.
I don't know exactly.
Later we have a software.
It's not open source. Inverter sold its software, but you have to buy it.
Okay.
So you can plan.
I know. I know this one. Yeah.
They on their website they have a 30 days trail time free of charge. Okay, we're back to the system design manually. So first things you will check panels VOC, panels IMP data, and normally for the hybrid inverter, all these panels should be connected in series. So you need to put the current is the same, and the voltage should be multiple. How many panels? The multiple the panels quantity, and so also when you, for example, for the 5K single phase one, when you do this 1.5 times PV hour size, normally the hybrid inverter rated power is 5K to the load, and the excess energy will be charged to the battery at the same time. So when you after you consider calculation the PV site, next step you need to design the battery site. Both of single phase and high three-phase one, they can use lead acid battery or lithium one. So these two have a different SOC. Normally, the lead acid battery only have the 50%, not that low. And also the size and the lifetime is much shorter than the lithium one. For the lithium battery, the SOC can be discharged up to 10% or even lower, like 5%. And the size of lithium one, it will be very compatible. And normally the lithium battery lifetime is more than 5 years, up to 10 years. When we talk about the battery, after you select the different type of batteries, next is we need to calculation how many battery or how many kilowatt hour battery we need. The typical ones, the battery capacity is matched with the inverter size. But if the user have more consumption or needs, the battery bank should be double or even triple. Depends on what's the consumption load they have and what's the habits energy, or what's the energy consumption habit they have. So that's a point to. Normally when you design the battery size, we need to know the user's all year round consumption electricity bill each month, and which month is high, which month is lower, and you get an average monthly use, and then to calculation the battery capacity. In that way, you will not spend more money on the battery, and you get a reasonable battery design. So the single phase inverter equipment with the CT and also smart meter is optional. So the smart meter and the CT actually the same function. One is anti-feeding energy to the grid. Another is detect the energy direction, maximum usage of energy generated by the PV to local load. Single phase inverter, we provide two different smart meter. One is a smart meter without CT. Another is if the residential load is bigger than 10K, up to below 40K. So this kind of application needed to choose another smart meter with CT. So we finished the PV configuration design, battery design. Next is you need to consider EPS load. So how many loads you can connect with the inverter, especially during the off-grid mode. Make sure this critical load still works without any problem. Also for this generator selection, we recommendation the generator's power is 2 times bigger than the inverter. The generator 2 times bigger than the inverter. When this load need more power, the generator can be feed the gap. The generator will provide the energy according to load demand. When the load demand is low, the generator output low. When the load need more, generator provide more. So why we recommend 2 times means during the off-grid mode, the generator could provide the energy to the load and charge the battery at the same time, if needed. I think that's a major procedure to design a hybrid system. So for the three-phase hybrid system is the same. First thing is to design the PV side, and then battery side. Three-phase inverters provide the smart meter standards. Also the same function we mentioned previously. And also for the battery side, a three-phase inverter only works with a high voltage battery bank. The stackable battery right now can be for the normal version. For the normal version, the minimum battery pack should be 3 because the lower threshold of battery is 150. So need 3 packs together to reach this threshold. But for the plus version, the lower threshold of battery voltage start from 80. So in that case, you can only connect with 2. That works. So based on the energy usage of user, you can choose 3 up to 8 stackable design. For the 5K, the maximum is 42. This is very big for the residential, but in some conditions, if the home have the electricity car, then this battery configuration will be works. It can charge the battery. It can charge the electricity car. So this is 2 type of smart meter we provide for the 3-phase hybrid inverter. One is without CT, only the smart meter, but the load should be below 50 kilowatts. Another is the CT with a current sensor. Our standard package for this kind of meter with CT can support 500 kilowatt load. So if the load bigger than 500 up to megawatts, you can only need to change the different size of rattles of CT is enough. So every CT have a right directions. On the CT they have numbers or arrows. So when you collect the CT on the line, make sure this direction is the same way described. Otherwise, the inverter can not detect the right direction of energy, and then in some of the operational mode cannot be working smoothly because the detect energy direction is different. So monitoring solutions, Wi-Fi is standards, but we also can provide the Ethernet 1, GMS 1, and also for the big plant, you can choose the power plant data log. They can only use one data log to connect in series many hybrid together. Also, the weather station could be choose to detect the temperature, irrigation, this kind of information to display the whole data on the app or on the web page monitoring interface. Single units monitoring solutions. The dongle will receive the data and upload to the grid server. And multiple inverters, the same. Here is the software we mentioned, it's PV6. Also, if the PV6 database is not the latest one, you can download this OND fields at Afore's official website to input this latest data sheet into the software. Okay. I think for the system application and design, it finished. I to the Jason.
Thank you.
Thank you, guys.
Hello, everybody. I'm going to go through initially how to install single phase hybrid inverter, and then we'll go through how to install a three-phase hybrid inverter. This is an AC coupled system. You can see on the bottom of there's no PV inputs. The battery input goes in here. We don't use COM1 generally, we'll only use COM2, and I'll show you on the hybrid in a moment what those connections are and why. Over here we've got live in, neutral for essential circuit supply, live for essential circuit supply, and the earth circuit. And this circuit over this side here is where the dongle plugs into. As you can see on here, there are no extras you need to buy for the inverter. The inverter comes with all the equipment. The inverter and the batteries come with all the equipment that you need. You don't need to buy any extra brackets or any extra cable packs or anything else like that, like you do with some of the other systems. If you can't, let's go back over there. I'm sorry, but if you can't screw a bracket on the wall, you shouldn't really be in, as far as I'm concerned. You can't, not able to fit that, so we're not going to go through that. This shows you how to connect the battery connections and what the fittings are that come with it. As I say, this is for an AC coupled system. There's two different forms of battery connection on here. There's the RS485, which go in pin 3 and pin 6. The more common one, most batteries, is CAN H and CAN L that actually goes into, that's actually a green plug that we use, the COM2. The battery connection goes into this green plug T, which is this that comes in the box, also uses the same green plug for the connections. AC connections for your live in, neutral in, essential circuit supply, neutral and live in. And obviously on the bottom, the isolator on the bottom of the AC coupled system. And then you can see on here, if you use a meter, the meter connection goes in 1 and 2 in the green plug. And if you use CT, the connection goes into 7 and 8 on this plug. Now unfortunately, I'm telling you all of this information and I've just found out the next generation of single phase hybrid is on its way, where we'll actually have 3 COM ports in the bottom of the inverter, one that is for a series connection, connection 2 for the RS485 is for the meter,
And city.
meter and the CT, and COM3 is for the battery. So in future, you won't actually need to go through the way I'm going through at the moment. You can actually plug an RS485 plug into each one of the connections that you actually need, and you don't need a green plug, so plug and play on the next generation of hybrid inverters that are coming in. Obviously there's an earth terminal on the side to be able to earth the inverter back to the batteries. This shows the hybrid inverter, which is what I've got in front of me here with the DC switch and the rest of the connections in here. Does anybody want to come up and I'll show you how this is all connected up? I'd always actually recommend that you did your wiring first on the bottom for your AC and for your essential circuit supply, and also your data cable link before you actually hang it on the wall. It's much easier to wire it up and then put a cover over it, make your cables off to the length that you actually require, swing it round, and then you can hang it on the wall much easier, and then connect it to your AC isolator. That's just a tip for everybody. It's much easier to do it that way around. On the bottom of here we've got COM1 and COM2. COM1's not required, that's used for parallel connection for inverters and for zero connection for firing up a generator. So in COM2 on the bottom of here, you use a patch lead in the bottom that goes in here. And then you connect this onto the green plug in there, in the bottom, and that's numbered from left to right on the bottom from numbers 1 to 8. Bottoms there. With our batteries, you will use an RS485 lead out of the bottom. No, that's the wrong battery. An RS485 lead out of this battery that goes onto the inverter com input. Out of the inverter com input, chop the end of the RS485 lead off and wire it into 4 and 5. Blue goes in number 4, white goes in number 5. If you're using a CT, on the back of this, but you can actually cheat. Wherever the cable comes out the side of it, the side that the cable comes out is the side that points towards the fuse board. So towards the home rather than pointing to the grid. That's essential that you put it that way around, because otherwise it will be reading the imported electricity as PV generation. So if you get it the wrong way around, it'll charge and discharge the batteries. The white one goes into number 7 on there, and then black goes into number 8. And now I think that's a Phillips. No, you can't do that one on there. Yeah. So yeah, that's fine. So that always needs to point towards the consumer unit. Errors that you'll find on the front of the inverter when you first switch it on. Generally, depending on where the inverter's come from and how it's been set, it may have a JO1 error, a JO7 error, and a BO6 error. All that means is you've not set it up correctly on the front of the inverter at the time. JO1 and JO7 are where the inverter has been set to meters instead to a CT clamp. So you need to go into the settings inside the inverter, change the settings that you want. The BO6 might be that the inverter is actually set to no battery or set to the wrong battery. So generally what you do with that is you go on to, initially on the inverter, go into system parameters, check your country setting, check your language setting, so you make sure you can read it in your language, and then set the time and date on it. Once you've done that, you can then go into the run parameters and then set up the inverter so that it's got the correct usage. So you say set it on self-use and that it's set on independent for the PV array, that there's not more than one inverter, so you don't need to set it in parallel, set it in on independent. You also in there set in the run parameters, you will then set the battery type, so it'll say lead acid, lithium or no battery. So you go onto lithium. If you know which brand of battery it is, you can go down to the brand of battery and you can select it, or you can go onto auto select, press the select button and it will scan for the most suitable battery that it's being installed with. After that, you then set the CT or meter, so it knows what it's actually reading and where it's reading from, as far as that's concerned. There's also on that where Don was talking earlier on about self-use, time of use, and the other settings that you can set as far as those are concerned. There's a setting on the front of here or on the app where you can set it for AC charge and AC charge times, forbid charge, do not discharge times, can all be set on the front of the inverter so you can clearly see what you're doing without having to go over to a computer and then log in to do it that way around. You can get to all of the screens you want to. Yeah. The battery connection goes in there with positive facing towards you and then negative at the back. And then you go out from, if you're having more than one battery, if you're having 2 batteries, 3 batteries, you then come out of the positive and negative on the battery into the next one. The first battery always goes into the inverter comp to come back to here, and then there's 2 battery connections on here for RS485. You use the second one, which is the output, into the input of the next one, and then the output of the other battery into the input of the next one. Does anybody have any questions? By the way,
I've got a question on this. I was asking Nico actually on this, but he didn't give me an answer. He doesn't know. If I have two inverters, hybrids.
yes.
How would you know?
If I have two inverters, I have 4 batteries that are, let's say,
Yes.
4 batteries, 5 kilowatt each. Could I somehow connect these batteries to both of the inverters?
No.
Or not? Or does it have some kind of connection between the inverters, like master and slave, so it can communicate from which one goes over the energy?
Yes, depending on the size of the PV array that you've got both of the inverters connected to, if they're both the same size PV arrays, I'd say put 10 kilowatts, two 5 kilowatt packs on each of the inverters.
Yeah, but I cannot do that because I have, let's say, two packs that I have 100 volts, 850 minimum to run this inverter on a hybrid. They have, let's say I have a home that has 2 inverters. I don't need a bigger battery than 20 kilowatts.
Okay, sorry, are you talking about single phase or three phase?
3 phase.
Sorry, I was answering for single phase as far as that's concerned. Yes, you could put that then on one battery, which then gives you the voltage that you actually require, and then tandem up the second 3-phase inverter, which would then, basically what that would do is then the second inverter would lift the base load of the property up, so you would need to be using less of the battery power from it.
I do understand that, but I won't be able to charge the battery, and I won't be able to, let's say, this, one symbiotic relationship. These
Well-
inverters are one battery, right?
Yes, you will be able to charge. You won't be able to charge the other battery directly from it, but because you've got a master and a slave, wow, this is a good question. Because you've got a master and a slave inverter, it would mean that the surplus that you would have from the inverter without the battery on would mean that there was more energy left from the one with the battery on to actually charge the batteries. And if it sees it exporting out, it's going to charge the batteries then at its maximum rate that it can.
So then it would use it on both sides.
Yeah, indirectly, yes.
I would connect both of them together, right?
Yes. Any other questions? On the single phase first? We can, is it 6? We can connect up to 6.
What do you mean 6? Oh,
6
6 units.
Yeah,
parallel.
You can use a maximum of 6 hybrids connected together on a single phase supply. You probably wouldn't have a need.
Is there a way to use, let's say, 3 single phase to generate 3 phase? I mean, for example, Growatt has that.
Yes, but you need to have individual batteries on each one of the inverters, and then you're not sharing the batteries between the phases. Whereas if you use a 3-phase, you're only using one battery, which can then be distributed between the 3 phases. So if you've got imbalanced phases, you might end up finding out that one of the batteries is getting used really hard and one of them's not getting used very much at all. It doesn't really make sense. If you've got a 3-phase supply, it doesn't really make much sense to put 3 single-phase hybrids on it, although you can do it.
So you will also move the phase of 120 degrees.
Sorry?
You will also move the phases.
It would balance between them on the phases, as far as that's concerned. Oh, if you use lead-acid batteries, you do need to have a temperature sensor that you put onto the batteries that you then wire back to the inverter. I don't suppose any of you will use lead-acid batteries, but you do need a temperature sensor if you are going to use lead-acid batteries.
Comfort for the batteries.
Fire.
Now you're talking about the lead acid, so you don't have any communication between the battery and the...
No, just a temperature sensor on there, that's it. And it will measure the voltage to give you what. It's kind of a bit of a crude way of doing it, but measure the voltage to find out what the percentage of the battery charge is for that. This could do that. I wouldn't really advise it. But yeah, you can set the top end, the upper end limit in certain settings within the inverter. You can set the upper end limit of the voltage of the batteries and the lower end limit of the battery, of the voltage of the batteries, and also the charge and discharge rate that can be set within software as well.
So it will out of comport or communicate. It's not.
You can do it, but I don't advise it. Yes, yes. Oh, sorry. If you're using a smart meter, the connections are obviously RS485 connections rather than the CAN H and CAN L. And in the connection on the bottom of on the green plug, you use 1 and 2 instead of 7 and 8. So you use the opposite ends of the connections for wiring up the metering solution instead. This gives you the dimensions of the 3-phase hybrid inverter. And obviously this is the same again. This comes with all of the cables and connections that you actually need for the connection of the complete system for it. Shows you the connection for your solar input. You put into the inverter. So the battery connections into the bottom of the inverter. Same again on here. The positive faces towards you and the negative is at the back. So provided that they're that way round, you know that you've always got the connections the right way round. Now on the 3-phase inverter, the connections for the battery connections and the metering or on the single-phase inverter connections. There's a port down here which is COM3 that you use the connections for that. And then you use COM1 for your metering connections on there. And as you can see on here on the right side, this gives you assignment for your CAN H and your CAN L of 1 and 3. Back of them for connecting that up. And then you put your Cat 6 or whatever cable you're using. We always recommend that you use screened data cable for it, and then you can wire that down to the battery and then connect that in. Now, something you need to consider when you're is make sure that your L1, L2, and L3 inside the inverter are the same L1, L2, and L3 that you actually use in the meter. And if you're using it with CT clamps, make sure they go around the same phases as far as that's concerned. Now, that's even more applicable if you're wiring more than one inverter up and you're putting 2 of them. You need to make sure that each one of them is on the same phase. So L1 is L1, second inverter, L1 is L1, so on and so forth. Otherwise, you can potentially get into all sorts of issues as far as trying to monitor what's being used on what phases as far as that's all concerned. You give you a headache and 2 days of extra work, ripping it all to pieces, scratching your head and trying to find out what the problem is with it. As far as your connections on the top of here, you've got a backup circuit and you've got a grid connection on here. Your top connections on the front are your L1, L2 and L3, which are these here. L1 is this one, L2 is this one, and L3 is this one. So it goes from left to right. The 2 connections behind are your neutral and your earth connection. The earth connection is the one on the left-hand side behind, and your neutral connection is the one on the right-hand side behind. So make sure you get those right, please. And obviously also there's the same out for the essential circuit supply if you're wiring an essential circuit supply. Just out of interest, how many people are actually wiring an essential circuit supply at the moment, or are you just all wiring? Let's start off with another question. Has anybody installed a 3-phase hybrid of Afores yet?
I did, yes, I did.
Yeah? How have you found it? Yeah?
But I never put the backup on.
That was the question is, there's a lot of installs that are going ahead, and there's quite a small amount that are actually even using a backup supply because of maybe some of the complexities about wiring a separate fuse board and separate essential circuit requiring to do that. It's an upsell though. potentially something else, gain some extra revenue from. So that's the AC wiring. And this is now wiring for the meter. The meter point goes in COM1 in here. See on the right hand side there, meter port pin assignment, 1 and 2 are A and 3 and 4 are B, which goes back to COM1. You use the same points for those for wiring extra inverters up. In and out and in and out as you go along for that. And that's why, I don't know whether it's 1,000,000% true, but it's unlimited. I don't know how many inverters is unlimited. I think we could get quite a few. I don't know whether there is an actual limit. On these, going back to these for a moment, on the CTs, because these are digital CTs on the single phase, we've actually connected one of these up onto a 100 metre drum of cable to try it, and it still works, which is quite good. Sorry, your question?
Yeah, my starter bought 6 inverters of 30 kilowatts, hybrid one, but she now has a problem that the CT, this one, the big one, you can see this one, he has got a problem that from the entrance of grid has 1 per 2,240 meter of the wire, the width of the wire. And he couldn't pass the wire inside the CT.
What size is that CT clamp, do you know?
It's from this inverter.
From
Standard.
Yeah. This
hybrid
one.
system?
Hybrid system, yeah.
3-phase hybrid?
Yeah.
30K.
30 kilowatt?
30 yeah。30的。
30
30的
kilowatt.
离器，那个少了24平方米的卡进去。
You mean the cable couldn't fit it?
Yeah, couldn't fit it.
We're talking
Yeah.
Chinese, sorry.
Yeah.
Oh.
So maybe what they should do, that's a problem.
We
The
need
cable is from your side. The cable is
It's from inside.
from Italy.
Yeah.
Is that the supply size cable that's fit round, is that what you say?
Yeah, it's too small, the hole.
Yeah.
Yeah.
We need to get some bigger CTs then, wouldn't we?
Yeah, change the big city. Change the big city with a big hole in the middle.
Yes.
That will works.
Maybe also the meter, because there are 6 inverters in parallel. I don't know if the meter can support everybody, every inverter.
Yeah, probably if the wired off a supply doesn't matter necessarily which, off a supply, but the CTs around the incoming supply, the meter will send the signal from the CTs so the meters don't necessarily have to supply all 6. Actually, my brain's starting to struggle with this. You won't need to actually wire it directly in line for the inverters, provided the CTs are on each one of the phases.
Yeah. Maybe needs a larger CT.
Yes.
Cables coming into the circuit breaker.
I had a
bigger.
yeah, but it's not necessarily the cables coming into the circuit breaker, it's the main cables that's coming into the building.
But you don't put it around the main cables, right? Around the M1 for one phase and the 3.
Oh, in the just below the isolation unit in the fuse board.
Yeah.
It could go there.
Yeah.
Could go
That's
there.
why it should, right?
Well, it depends whether that's a main fuse board or a sub board, doesn't it? Because it could be there's a main supply coming into the sub board off it.
Measure one lead, not the whole bundle. Right?
Yeah. You've got L1, L2, and L3. Yes.
So, yeah, I cannot imagine that they get one bigger than the Sentinel.
Right. Okay.
So I think they.
I've got one from last week where they've got 120 mil cables coming into the.
Yeah, but they talk about what made it's like.
Yes. If you want to speak to Carrie about that, Carrie can get that organised and sort it out for you.
Before the circuit breaker.
So this is the example that we were just talking about, whereby the size, because it's less than 50 kilowatt, the meter can take the size of the input tails into that. Larger than 50 kilowatt, the size of the tails might be a lot larger, whereby you can't physically get them in the meter, and then that's why you then use the chosen connection for the Wi-Fi going in, and obviously the isolator for the PV. This shows you that's a single phase hybrid. We'll jump there. That shows you parallel connections, multiple connections for single phase inverters. And this is what we were talking about earlier on for the three-phase inverters, where this connects into COM1 at the top on the input on the bottom of the inverter. Out of there, you'd have one that'd be the master, and then connected down, in and out to the next one, and then in and out to the next one, and then back to the meter. So that one would actually be set as the master, because that's the first one that comes back from the meter, and then these other two would be slaves that then take their information from the master inverter and backwards and so on and so forth.
I have another question. When I put all together in a smart meter, I just have to put one logger, right? One for the internet logger, better, on the master one.
Not 100% sure.
No.
Each inverter
Each inverter.
with a
Yeah.
separate logger.
So in the app, the final client will saw 3 loggers or all in one logger.
They can
They can
create
check
a project.
Uh-huh.
In this project, 3 loggers as serial number will be displayed in the same project.
So he in the app, he could just see 30 for every inverter, not plus the total.
There is a,
In the dashboard, you can check the total energy. And inside the device you can check individually inverter's working station.
Any other questions, anything else?
The cables from the battery, they are 10 square millimeter. Sleeves with it for 10 millimeter. You can put it in the back.
It depends which battery manufacturer you actually use. Yeah, there were some oversized cables. We experienced that problem as well. We actually got some replacement cables, or we cut down some of the cables on there because the size of the cable was far too big, oversized for the discharge current of the battery anyway. So it didn't matter if we just chopped a few of the strands off it. That's what we ended up doing. That was on an early delivery, I think that was. Shouldn't have that problem now. But yeah, good point. They won't fit in with the sleeves.
Your breaker. Your breaker.
But not anymore.
你先放下视频的，你先说，你说一下。
Next stage is 10 millimeters. If batteries are a long way from your inverter cable phase.
I wouldn't recommend you install the batteries any more than sort of a couple of meters away from the inverter, 2 or 3 meters. Probably advise you if you've got higher discharge capability, if you're using a bigger inverter by the size of the cable you're actually using, if let's say you've got like 20 kilowatts on a single phase battery, you're going to want to set that to discharge at its maximum rate for it. So I wouldn't go too far.
And they're rated for 100 amps or so?
Sorry?
Are you rated to 120 amps, the cable?
I'm going to have to refer back to you on that one. I don't know off the top of my head.
So the inverter is rated at 120 amps, right?
Yes, but I don't know what size those of the cables were for on the 6 kilowatt. Or less than that, you set to 80 amps anyway on the current charge and discharge rate.
Okay.